Good morning, doctor. This is the question 1, got 3 parts. For a signal xt equal 20 e exponent negative 0.1 t ut. So we need to find dtft. Okay. This is my answer. xn to find xn will be xt multiplied to nts. Nts is the sampling frequency, so we need to find the sampling frequency is 10 Hz, so ts will be 1 over fs, so we get 0.1 second. So the sampling xn we get 20 exponent negative 0.01 n un. So no more ut, so become un. After that we need to find x omega. So x omega formula is summation n equal to negative infinite to infinity xn multiplied to e exponent negative j omega n. So as xn is a unit step function xn, so unit step un. So un function, unit step function is will be before zero will no value. After 0 we get finite value equal to 1. So we'll just summation for n equal to 0 to infinity. So we substitute from xn multiplied to exponential negative j omega n. So after that the answer will be 20 over 1 minus e negative 0.01 negative j omega. Okay. For b, you need to find the sample signal when n equal to 0, 1, 2, and 3. Okay, this is my answer. When we get the sample signal xn, we get the formula 20 exponential negative 0.01 and un. So we just substitute when n equal to 0, x0 means that n will be equal to 0. So we substitute to this formula, so we get 20 as n equal to 0. So we get 20, and after that n equal to 1, so we get 19.80, and n equal to 2, so we get 19.60, and n equal to 3, we find out 19.41. After that, the last part of question 1, we need to find 4 point we need to find xk dfc. After that, we need to calculate the value of x3. So this will be the answer. So this is 4 point means n equal to 4. So the k will be start from 0 to 3. So that will put in our xn from part B and use it to xk formula for DFT. Okay, the summation from n equal to 0 means k k to n minus 1 xn wn kn. So we need to use this formula from because we need to find x3, so you need to put tabulate the value from x0 to x3. And this is the formula. How we will get the e negative j pi 3/2. We refer to this calculation when e exponential negative j pi. We use cos pi minus j sine pi. So we calculate this and we get the answer for x3 as e negative j pi 3/2 is j, and negative j pi 3 is -1. Negative j pi 1/2 is negative j. So the answer will be 0.4 plus j 0.39. Moving forward to question 2. For the question 2, the equation has been edited, modified to 2yn, to this one, question 2, 2yn equal to xn plus 1/4 yn -1. So we will arrange to different equations. 2yn minus 1/4 yn minus 1 equal to xn. After that, for question A, it needs us to find the impulse response hn, which is hn. So we replace the yn into hn. So we get to hn minus 1/4 hn minus 1 equal to xn, which is delta n. So when n greater than 0, 2 hn minus 1/4 hn minus 1 equal to 0. So delta n will be 0. Because delta n will be the equation, the function of delta n will be at one point at 0 only had 1. So if greater than 0 will be equal to 0. So when we need to solve this equation, we need to replace hn to zn. So after that, we get 2zn minus 1/4 zn minus 1 equal to 0. So we divide this one, so we get left z only. So as if we get z equal to 1/8. So hn will be equal, back to the equation, hn will equal to zn. So it's 1/8n times k. So when we need to find k, we need to know what's the value when n equal to 0 and n equal to -1. So when we get hash 0 equal to k and hash -1 equal to 0, so we substitute again to the main equation. So finalize k equal to 1/2. So hn will equal to 1/2 times 1/8n un, and when we get this formula, we also can get hash n when n equal to 0, n equal to 1, n equal to 2 until n equal to 3. Okay, we're done for this. So hash n value will be 1 over 2 when n equal to 0, and n equal to 1 is 1 over 16, and forward. So we move forward to the last part of this question. You need us to a given input signal xn equal to 2 over 3n un in the system. So you need us to find system output in the frequency domain and time domain for the latest question. So frequency domain, we can either use Z transform or omega transform, or equal the TFT. So for the B question, we find out xn is 2 over 3n un, and hash n is 1 over 2 times 1 over 8n un. So the convolution, we need to do the convolution. After that, we need to inverse Z transform back to the yn. So xn yz is equal to xz hash z. So we need to find xz in Z transform. So in Z transform is summation from n equal to negative from infinity to infinity xn times z z to negative n. So when we all using un, so the summation will be n equal to 0 until infinity. So we will get exact, the answer will be 1 over 1 minus 2 over 3z. As we know from the formula, from the transform pairs, we get it an un, we will transfer to z over z minus a, or 1 over 1 minus 1 over 1 minus n a over z. So this is from transform pair. So we also get hash z equal to 1 over 2 over 1 minus 1 over 8z. So after that, we need to multiply to get yz, we need to multiply xz to hz. So this will be the answer, we get it. So as we done for the frequency domain in yz, so we need to do the time domain to inverse it, inverse z transform to get yn. We need to use long division, or equal partial fraction division. We will break it down to two parts, A1 and A2. Okay, and after this we solve this problem, and to get A1 equal to negative 3 over 13, A2 is 16 over 13. After that, we substitute into the yz, so we separate to get this answer, and then we'll make the transform pair again to get yn. So yn will be negative 3 over 26 times 1 over 8n plus 8 over 13 times 2 over 3m un. And if you would like to do omega